Hey all, welcome back to my channel Daily Code Dive. So in today's video, we have a question: how can we get the height of binary tree? So before even starting how to calculate the height of binary tree, I will first explain what exactly the binary tree. It's actually a number of nodes which are present on the longest path from root to leaf. With that, what exactly I mean that, see, here we have three leaf node, right? 4, 5 and 7. If you see its path, so for example, let's suppose I have taken 4, leaf node 4. So if I see how can we reach up to the node 4, we will first start with 1, then 2 and then 4. Okay. Similarly for leaf node 5, we will see how can we reach up till 5, 1, 2 and 5. Similarly for 7, how can we reach up till 7, 1, 3, 6 and 7. So that means to reach up till 4, we have to traverse all these nodes. Then only we'll be reaching 4. Similarly for 5 and 7. So now if you can see how I have defined the height of tree, the number of nodes present in the longest path from root to leaf. Here if you can see how many nodes we have, 3. Here also 3. But when it comes to the node 7, we have 4 nodes, okay, which are coming from root till leaf. So that means the height of this binary tree is nothing but 4. So this is how we can actually define the height of binary tree. I'll take one more example to show. So example, let's suppose we have this tree. Okay, 1, 2, 4, 5, 6, 7, 8. Now here by visually also you can see that the longest path which can offer that can be offered by leaf node 8. Okay, so let's calculate it. Okay, we have 2 leaf node, that is 8 and 5. So I will start with the 8. So to reach up till 8, what it is, 1, 2, 6, 7 and 8. Now to node 5, we will start from 1, the root node, 3, 4, 5. This is the path to reach up till 5 node. So now if you calculate how many number of nodes we have actually traversed in the case of leaf node 8, 1, 2, 3, 4, 5, that is 5. But when it comes to the leaf node 5, that is only 4. So hence the height of this tree is nothing but 5. Okay, so this is how we can calculate the height of any binary tree. So now that we know that what is height of tree, let's move towards its code and algorithm. To solve this problem, we will actually use recursion, and it's not like we can only solve this problem via recursion. We have an iterative way as well. So in today's video, I'll be explaining recursion way, how we can use recursion to solve this problem. And trust me, with the recursion, this problem is very easy. You can easily solve. So the main fundamental is that to start with a recursion problem, we need to first understand the main problem, and then we will divide it into the sub problem, and then we will have one base condition, right? This is the way how we apply recursion to any problem. Okay, so here in this case example, I'm again taking one binary tree example. Let's suppose this is a binary tree. 1, 2, 3, 4, 5 and 6. Okay, so this is one binary tree. Now if I want to calculate the height of tree, okay, the height of tree depends on the height of these two subtree, the right subtree and the left subtree. If somehow we get the height of this subtree, right, we can also get the height of the root or the tree, right? And similarly we can, so I have basically divided this problem from main problem, that is to calculate height of tree which has root node as 1, to we are basically calculating the height of subtrees. Similarly we can bifurcate it again. Now to get the height of this tree which has the root node as 2, we can divide it as like to get the height of this part and to get of this part, right? So now if we get, so here you know that this is how we can basically divide this problem. We will to get the height of this node, we will divide it here to, we'll first calculate the height of left subtree and the right subtree, and in that whatever is the maximum, right, whatever is the maximum height, that will be the height of this tree. Okay, so in each step you can see, in each step what we are doing, we are first calculating the height of left subtree and then the right subtree, and in that what is the maximum value that we are basically is the height of tree. Now this is about the how we are basically dividing this problem. Now what is the base condition here? Okay, base condition will arise when we reached here. Okay, let me first clear this out. Yes, so base condition lies here whenever we reach to the leaf node, right? So when we reach to the leaf node, you can see at any leaf node, do we have any other node? No, right? Because it's a leaf node. So what is the height of a single leaf node? That is only 1, right? So that means when we are further traversing from after leaf node, so what we will get? We will get the null, right? If we see what is the left child of 4, that is null. What is right child of 4? That is null. So as soon as we get the left child and the right child as null, what we will return? We will return base condition as 0. So whenever root is equals to null, okay, then what we will return? We will return 0. Okay. Otherwise, what we will return? In other cases, let's suppose we are here, okay, root 2, what we will return? We will return the maximum between left subtree height and the right subtree height, that is we will return max of height of left tree and height of right tree and plus 1. Okay, so plus 1 because here we are see here, if we have this tree, okay, we have got the height of this tree, we also have got the height of this tree. Now to include this one, that is also comes inside the height of when we are calculating the height, right? So that is basically plus 1. Because of that we have added plus 1, right? So in each case what we are doing, we are basically when we have to calculate the height of root node which start with the root node 1, what we will do, we will further go to the height of, we will calculate the height of this subtree which will start from 2 and height of this subtree which will start from 3. So now I hope you will be able to imagine the solution, right? So I'll again clear this out. Now we have the base condition, right? So at each time what we are doing, we are calculating the left height, that is again we are calling the same function height and root left, and then height of right tree, that is again we will call the same function because we know the subproblem is also same, right? We have to calculate again the height of subtrees. So now root right, and then what we will do in the end, when we have got the height of both subtree, what we will return? We will return the height as maximum of LH, that is left height, and right height plus 1. So this is how the algorithm part is. This is how it will get solved. And yeah, I'll also define the function. Let's suppose we are calculating function where we are passing the root, and return type is integer because we are passing the height. So yeah, this is the algorithm part. This is how we'll implement this complete algorithm in the form of code. See, whenever root, as soon as root reaches to the leaf node, okay, that means it will, when we are leaf node, and then when we are moving towards its left and right child, obviously it will return 0 because we don't have anything, and obviously height will be 0 at that time. So it will return 0. And this is for whenever we want to calculate the height of subtree. And we know, even we have bifurcated this problem, like to the main problem, to the sub problem, and then again we have a same sub problem that at each step we are calculating the height, at each node we are calculating height. So that for that we are basically moving towards its left and right child, and we are calculating its height, and in the end we will return maximum of LH and the RH, that is height of left and right tree, plus 1. So it's very easy. So let's move towards the LeetCode problem. Yes, so now here we have a LeetCode problem where we have to calculate maximum depth of the binary tree. That is nothing but the height of binary tree. Here, as I have explained in the algorithm part, when I have explained, the same thing I have implemented here, that with the base condition is that whenever root is equals to null, we'll be returning 0. Otherwise, we'll move towards its left and right child, because from there also we'll be doing same thing. We'll be calculating the height. So same thing, same function I have called here, recursion. And then in the end, what I am doing, I am returning this maximum between left height and the right height, and plus 1. So let's run this code. Yeah, so it's working, right? Now I'll submit this code as well. I've already executed it before also. It's just I'm showing it again now. So yeah, so this is how we can, implement this code where we are actually calculating height of node. I hope I'll be able to explain this thing very well. So yeah, let me know if anything is missed, or if you know any other better method. Yeah, thank you so much.